we know how to,
Welcome, everyone. I'm not Trevor. I wish I was, but I'm not. My name is Kamil Kiliański. I do work at the European Commission, and we would like to welcome you jointly with Geoscience Australia to this session on Copernicus and Pacific Islands. You will hear later today about Copernicus and how it could be of use to the region through very specific case studies discussing marine, atmosphere and other very relevant topics. As you might know, Copernicus is a very rich ecosystem and a very prime example of Earth observation system, which is free, full and open, and thus very useful to many stakeholders in the region. It's particularly beneficial because of the international cooperation, not least in the geo context. At this juncture, I would like to pay tribute to Dr. Astrid Koch, who's been tenacious, unwavering, and very effective in our international activity. Of course, the crown jewel in this activity is the cooperation agreement with Geoscience Australia, which was achieved in 2015, and the original data hub, of course, resulted in many other good things. We see it also in the broader context of the Paris Agreement and the Sustainable Development Goals. So, without further ado, just let me finish on a somewhat personal note. So, I'm a neophyte in the Earth observation family, so to say. I joined only half a year ago, but what was decisive for me to abandon my otherwise more or less successful career in antitrust and intellectual property was the fact that very few areas in the European Commission activity you actually affect real life of people so far away, like in the Pacific. And I think this was quite decisive for me to make a small contribution to the Earth observation, and hopefully that through this session and the presentations you'll be as inspired as I was. Thanks so much, and over to Trevor.
So thank you, Camille, and thank you to all of our colleagues from Europe for facilitating this event and for, frankly, being our partners in terms of setting this up. Before I start, I actually just want to quickly acknowledge the country upon which we are having this meeting today, and to particularly acknowledge the traditional custodians of the land that we are meeting upon, the Ngunnawal people, acknowledge and respect their continuing culture, the contribution they make to the life of this city and this region. And I'd also like to acknowledge and welcome any other Aboriginal and Torres Strait Islander people who are here today. I particularly, though, as I said at the start, want to highlight and thank our colleagues from the European Commission, because Australia feels very, very blessed and very lucky both to be the first data hub, the jewel in the crown, as Camille referred to it, but also for the investment that the European Commission has made in the Copernicus missions and the work that they have done to unlock that data. And we really see ourselves in Australia, through the Copernicus Data Hub, as partners to Europe to help them unlock the value of this incredible resource that is represented by the Copernicus missions. So for those who don't know, and Alla Matlenko will talk about this in a bit more detail later, but we currently, on behalf of the European Commission and a consortium of partners across Australia and New Zealand, download all of the Copernicus data for the region that you see on this map. And the point of this presentation today and this whole session today is to highlight that we're not just collecting data for Australia. We are actually syncing data from Copernicus to the region for this entire part of the area, and in particular for our Pacific Island neighbours. And I just want to quickly highlight the fact that not only are we downloading this data, but already it's actually starting to have some use, albeit only embryonic, but across the Pacific Island nations. So if you have a look in the last month, the top data queries from across the last month, these two highlighted in green are both actually businesses based in the Pacific Islands. I'm going to look to Simon for accuracy. They're Fiji, is that right? Simon doesn't know either. New Caledonia, my apologies. Oh, there we go, one of them's here today. So, and they've come all the way to Australia as well. So the data sets are beginning to get some use, but I think we would all acknowledge that there's a vastly further way to go. And in fact, as I understand it from the Talanoa that was held in this very area yesterday, there was a point led by the Pacific Islands recognising that they now want to think about and articulate how they would like Earth observation to help them drive sustainable development into the future. And I think we stand here ready today as that vision becomes clear and as the Pacific articulates how it wants to use Earth observation data, we stand ready to support. At a bare minimum, we stand ready to support with this data that is being brought to the region today and is being made available. But we can always do better in how we make it available, and we are very open to improving that as we go forward. And I also just want to highlight, while we can do better, we actually already have the top 4 downloads in the last month of data downloads. Number 3, France. I'm not going to judge, but thank you, France. But number 4 is New Caledonia. So if you have a look at that, now that's only the last month's statistics. They're not huge numbers, but already by bringing this data to the region, the partnership between the European Commission and the Australian government, New Zealand government and all of our consortium, as well as the work with ESA and EUMETSAT, is already starting to bring this incredible asset to the region. We are really, really proud to be part of that, and we are very much looking forward to working with all of you, to talking today about what those resources are and thinking about how we can do better at unlocking that resource for Australia, New Zealand and the entire region that the Copernicus Australasia Data Hub covers. Thank you very much and welcome.
How does this work here? What happened to the end slideshow? But you know.
Sorry, Astrid.
What? Okay. You know, the cursor is not. You know, I'm not sure how to get away from your presentation. Look, I want to get. See, there's no. Yeah. Nothing, so. IT is important, but now I don't know how to. Yes, okay. So, I'm giving a very short overview of the Copernicus Programme. It's only 10 minutes and it's going to be very, very brief. As I know, this presentation is being recorded and will be available on YouTube. And the presentations will also be made available. So, no problem if I go very fast, but you know, the Copernicus Programme is a program to monitor Earth and also support crisis and security risk by getting, making sure we have data and services available. And what's important is it's on a full, free and open basis. And as we heard, New Caledonia has a company, so we are supporting economic development, not only in Europe, but also worldwide. So let me see. Just a brief overview of what is the Copernicus Programme. Is a hybrid program consisting of dedicated Sentinel satellites. These are a suite of satellites which have all different features. We have altimeters, optical satellites, radar satellites, and we get in situ data, and we're having contributing missions from across the globe, from France, from the United States, from private companies, and all this comes together into models, and then we prepare value-added products. for me, important to tell you is for the Pacific Islands, the data from the Sentinel satellites are full, free, and open for you to download from the hub or from the DIAS, but also the products are available. The products are global products which are updated regularly, but they are not designed specifically for the Pacific Islands. If you want to do this for your Pacific Islands, you have to enlist academia, a company, or, it's up to you. It's your decision what to do with this. Just a hint from my part, we have a Directorate General for Development, and they might have projects or funds available to help you with this. The Copernicus Programme funds the satellites, the infrastructure, the services, but we do not have funds for international cooperation or development. We have to, we are working together with our partners to do this. So, just an overview here of the suite of satellites. We have currently 7 satellites in space. Data is downloadable from the regional data hub. Here are the contributing missions. What's important here, it is subject to the owner's data policy. That means they are not all full, free, and open, depending on what you want to do with this, but you have access to this data. What is a very important component is the in situ data. We need that for calibration validation, and we would like also to reach out to the Pacific Islands because you have a valuable resource for us. That's your in situ data. So we will be very grateful if we can work on a partnership to support the in situ data network in the Pacific Islands. What is currently happening is we have Sentinel-2 coverage, which includes the Pacific Islands, and we have increased coverage of with Sentinel-1, that's the radar satellites, thanks to our partnership with ESA and EUMETSAT. So they are our technical experts who make this happen. What we have as a service, we have 6 different services which provide dedicated products which are also available to you. Land monitoring, marine environment monitoring, atmosphere monitoring, emergency management, climate change, security not so much because it's more dedicated to European questions and issues, but also supporting our international policy. Just to give you an overview, here you see the different areas for the land service, global, pan-European, and local, and you see what we have as products. Here's the overview for the marine monitoring. I'm not going to go into detail. We have a better presentation by Cécile. Here, the atmosphere monitoring, for example, ozone, UV, solar radiation products. Important is our climate change portfolio where we do reanalysis, but we have the estimates of the essential climate variables. These are all available for you to use. For tropical cyclones, we provide a rapid mapping in case there are tropical cyclone via activation of Copernicus, but we also, after a disaster, we are supporting by a risk and recovery mapping. And we are supported by the Joint Research Center and industry partners. How is the situation with the data? We have an arrangement with Australia. There is the data hub now also available for the Pacific Islands, but also because our open hub is very limited because it's very popular to get the data. We have now the Copernicus Data Information Access Systems where we have commercial consortiums to provide those platforms. We hear about this later. Here you see Stuart Minchin and Philippe Brunet signing our arrangement. And here is the overview of the Copernicus International Cooperation on the arrangement. What you see here, and we have here New Zealand is not in red. Why? Because New Zealand has a partnership now with Geoscience Australia. They are using the regional data hub, which is great. So just for your reference, here are the links to where to get the data. Here are the links where to get to the DIAS. What I want to let you know, we have Copernicus relays. These are knowledge hubs in each country, support to local users. If you want to become a Copernicus relay, just send an application. You're part of a big network, a big family using Copernicus worldwide. We also support the next generation, try to establish curricula, working with the academics. We have a Copernicus network, which is also worldwide. We also want to encourage Pacific Islands to participate in the Copernicus Academy. And this is just the end of my presentation. Was very fast, but I just want to make sure that the other speakers have also time to talk. So next up is the presentation of the data access. Alain will give a presentation about the regional data hub. Let's see. Yeah, I'm not sure. Look, see?
So just hit that
Yeah.
one there.
Yeah, well, how to get there?
Okay. Oh, you don't have a mouse?
No, there's no mouse.
Oh, that's... Oh, okay. Oh, that's interesting. We've lost the mouse.
Yeah, we lost the mouse again. Doesn't work. Hello.
We've lost the mouse. Welcome. My name is Ella Matlenko. I'm responsible for the operations and management of the Copernicus Australasia Regional Data Hub. I also oversee the relationships that underpin this collaboration with the European Commission, EUMETSAT, ESA, and our consortium partners who have conceived and help us operate this hub. You had Camille and Astrid talk about the ecosystem of access to the Copernicus hub and the jewel in the crown. This is basically a different view of how the access works. So you've got the open access through the hub where users can register themselves. You've got the mirror hubs representing each state within the European Union, and then the international hub is where Copernicus sits. And the DIAS is relating to the Copernicus services that Astrid mentioned earlier. The Copernicus hub is primarily used by our agency partners who've invested in the particular hub that I'm talking about at the moment. These are large organisations comprising of government agencies that use these particular data streams for their monitoring programs and research. Trevor has already shown you this map. So what our mission is to provide the fast, free and open, trusted, reliable, free data to our region covering this footprint. At the moment we're syncing Sentinel-1, 2 over that footprint, but Sentinel-3 is global at the moment still, and 5P will be as well. In the future we'll reduce the Sentinel-3 to that region simply because of the cost factor of storing the data. Apologies. So the different levels of data that we are syncing range from 0 to level 2. Just a quick snapshot of what that looks like. And at the moment, the current status is we're about, before I go on actually, the data hub is located in Canberra here, situated at the National Computation Infrastructure. So they're a partner of ours who enable us to park that data with the supercomputing facility, which enables it to be analysed by some of our partners in situ. The Digital Earth Australia in particular is one of the sponsors for this particular program here. The size of the hub is about 2,600 terabytes, which is about 2.6 petabytes, growing at approximately 1,400 terabytes per annum. So the graph here on your right identifies the user increase of downloads from the hub from April 2019. And that's when our Sarah, which we refer to as Sarah, I'll talk about a bit more in the next slide. Sarah is our regional portal by which you access it through the internet. So what we try to do is try to sync the data that's coming out from the International Hub within 24 hours. The graph here on the bottom actually shows us that we're achieving getting most of that data within the first 12 hours. So anything beyond the 24 hours is usually the non-time critical products, which is the Sentinel-3s, and we do have some lagging in some of the products. One of the challenges is making sure we're pinging the International Hub on an hourly basis and pulling that as quickly as possible, because some of the applications are relying on the latency and getting that product quickly. Just a quick overview of the density and the heat maps. These products is the Sentinel-1, the GRDN product, and the areas that I've got identified in blue, that's our particular footprint as shown in the previous presentation slide in the purple polygon. This is Sentinel-2. So basically we've got everything that the International Hub distributes over this particular footprint. This is the Sentinel-3. As I said, at the moment it's global, and we've got that full repository at the moment at the NCI. So this is the access portal that I'm referring to. So the www.copernicus.gov.au is our home address, and you can access it through the regional data access point. The Sentinel Australia Regional Access map-based GUI is our primary downloading mechanism. You can also download it through a Sarah Python API, which basically provides the bulk. A lot of our partners are using that. They've actually developed that and shared that information. So we're talking thousands of images on every week that are being downloaded. The NCI also provides another access point through our thread server, and then there's the NCI registered users where they've got the in-situ data sitting there with the compute. So this is the portal once you go in, and the preference is going through the Sarah interface and the API. So as mentioned earlier, the government programs that are aligned and support the Copernicus Australasia are those who are using these data sets for monitoring big programs, Australian Digital Earth Australia and Australian State Government Land Cover and Land Management Monitoring Programs and CSIRO in terms of their research and climate change and various other research entities. I just wanted to give you a small flavour of applications that we're using in our region. This is just a small example. What you're seeing here is this is an INSAR application showing a time series analysis of surface deformation. The shapes in the left image are sections of the underground mine. In both views, we are seeing the deformation on the surface above the mine over a 3-year period. Here is the same area represented using GPS. This graph plots the same mine site deformation as a measurement of geodetic grade GPS core stations as is measured by the INSAR. You can see that the INSAR results are as good as the GPS, and in addition, when the GPS had a power outage, you can see that on your right here in the green line, the INSAR has filled in the gap, so it is pretty precise. Here's another example. Geoscience Australia monitors and analyses and reports on significant earthquakes in Australia using seismometers, which provide rapid information on the magnitude and location of an earthquake. But the uncertainty on location and large areas of kilometres can be difficult to pinpoint where the particular earthquake commenced. Here in this image you can see where the star pinpoints the origins, and the dotted line is identifying the fault line, and you can see the deformation replicating the deformation across on the right hand side from that dotted line. So the INSAR is measuring the smallest measurements in the centimetres, which even millimetres to some extent. Here in the Great Barrier Reef, Sentinel-2 is picking up on the bleaching of the corals. As we all know, bleaching happens when the algae are living in the coral's tissues, which capture the sun's energy and are essential to corals survive, are exposed to owing to high water temperatures. Industry is leveraging off this data set as well. Here's an example of a company called SIBO. It's a startup company. They're basically feeding into the livestock industry here in Australia. Look, Australia's red meat industry is basically worth $18.4 billion, which is 1.6 of our GDP. And so basically they're using the Sentinel data to calculate fractional cover to get biomass volume and then overlaying that with the paddock to identify how many animals they should stock a particular paddock. I'm going to have to whiz through these, I'm running out of time. But this is another example of an early fire detection and intensity of fires using Sentinel and machine learning. So New South Wales, that was the fire example, apologies, but I'll just whiz through this one. This is the severity and mapping. The previous one was to do with clearance. Again, a New Zealand example, similar example of determining crop yield assessment and the amount of particular vegetation growing. You've got the time series in the blue. Bottom graphs is showing actually the dry mass on a kilogram basis. These are just some examples of the Sentinel products. These are being utilised by our partners. We don't produce them. However, these are just a bit of eye candy at the end. So thank you.
Thank you. So next one up is
Let me help you.
Representing the Dias WEKEO.
Is this you?
Yeah, it should be.
Let me help you here. And then,
It's okay, I'm on screen.
are you on screen? Do you want your talking points?
Thank you.
You're welcome.
So, good morning, afternoon, good lunch, everyone. So I'm going to explain you what is a DIAS. So it's an acronym for Data Information Access Services. My presentation will be based on the presentation of the WEKEO DIAS, that is one of the DIAS, I will represent that. But I'm trying to be as generic as possible because we are 5 DIAS involved, let's say, currently in the Copernicus environment, and I will try to give a flavor of what the other DIAS are doing too. So, as Astrid mentioned, the Copernicus, whoops, what's happening? I'm not in, okay. It's funny.
This is, I had the same problem.
It's just for me, my presentation.
Ella can fix anything, mate.
Hold on. So,
No, you're editing my presentation. It's okay.
why is that not working?
If we go on the slides, sure.
Try that one. What's the technical name?
Thank you. So, trying. Okay. So, back again. So, as Tud explained, we have, let's say, a lot of information providing from the Copernicus world, so all the Sentinel satellite and the Copernicus services. And this is
arithmetically growing set of data. So with, for Europe, 10 terabytes per day of new data. So this was creating some issues in terms of download of the data, because especially for instance, the Sentinel-1 data, when you have to download for doing in-SAR processing a stack of 200 images, you can easily collapse any distribution system. So apart from that, it was, let's say, the distribution system was spread between the different services, the different entities distributing the Sentinel system. So it was decided to create a kind of unified portal for both accessing the data in the standard way, but also to process them. So this is the famous idea of the DIAS, so this data and information access service. So currently we are having 5 DIAS available. So you may ask, why 5 DIAS? One should be easier for everyone. Yes, but this is a commercial activity. So it was impossible to create a local on a single DIAS. So it was decided to open, let's say, that to competition. And we have 4 DIASes that are, let's say, under ESA procurements. And one that is done by the Copernicus services that I'm representing, that are the one in charge of the WEKEO DIAS, so made by EUMETSAT, ECMWF, and Mercator Océan. Okay, so the idea is the following. Let's say the ESA DIAS were made of consortiums that were made under ESA procurement, so with several partners, so representing any required layer for the industry. So the guys are in charge of knowledge of ground segment, your experts, and mainly the cloud infrastructure, in order for you to be able to process locally your data on the cloud, not to have to download it. What we did in WEKEO is basically we do afterward another invitation to tender to select some of the partners, let's say not just them, so it could have the other one, that are also providing for us those layer infrastructure. So for Europe, this is creating more or less, let's say, the panorama of all the, let's say, commercial partners that are providing services on the behalf of WEKEO. Some of them are the same that are the one providing services for the other DIASes. Okay, so what is important to understand is that a DIAS is providing you the access to the data. So this is one, the first on the left column. So you get access to all the Sentinel data, to the Copernicus service, so the marine service, the, let's say, the climate service, the atmospheric service, the land service. Is not, you cannot get access to the, let's say, to the security and to normally the emergency, because they are under different agreements. But you can get access to those data. So now, when you have those data, you can either download them in the old way, but that is not recommended. What you can do is to process directly those data at the platform level. And that is very important. Afterward, you have the user support. To explain this, this download, let's say we have made this very basic graph that is the following. You know, you have, I don't know if you see the down, yeah, no, you cannot see it. So basically, you have the download part. Let's say, first of all, on the platform level, you can just go around and see some documentation and use some viewer of all the data. I will show an example afterward. It's very nice to see when you merge different sources of data. But what you can do in the old way, just having registered on the platform, is to download the data. So you can do that. It's not what we recommend, because we want for you to do the third line, that is the use local of. Most of the people are using a Jupyter notebook in order to process and do small processing there at platform level. So this is for free. You can do so. You may have your, let's say, your own small environment. For sure, you cannot store here a petabyte of data. It's not the idea. You have a few gigabytes of local environment for any user registering at this level of platform, and there they can process things. Of course, this is a kind of attractive layer for us, telling that, okay, once you get used to that, you want more processing capabilities, more storage capability, and you go on the bottom line, that is the one of the advanced processing. And there is entering, let's say, the commercial activity on which you can buy, let's say, your virtual environment with a certain number of CPU, of storage, and whatever you needed here. Okay, so that is basically the idea. We want to change the paradigm of this famous download of data that is collapsing any system now currently in the world in order to process locally at cloud level where the data is available. Okay, so this is the idea of the DIaaS. So just what I was mentioning before, this is what you can get directly at platform level. Let's say, visualizing the data. You can merge. In this case, I cannot see what we have on the left. It's too small. But we have, for instance, in gray, the Sentinel-1 data. Always the pulsar is always in gray. You know, you can put some color on it. But you have also some currents coming from the marine services. You have some information coming of temperature from the ECMWF. Many things. So everything is available at the same place. But the idea is, okay, you can either locally view that or process it, if possible, with GCP notebook at platform level. Okay? So let's go to the specificity of the WEKEO offer. So this is not as generic as the previous thing, because this is really something that concerns just the WEKEO DIaaS. So the WEKEO DIaaS is based on a different idea than the other DIaaS. Most of the DIaaSes are just copying all the data on a single cloud, so making copy of 12, 10, I don't know, maybe some of them are at 20 petabytes of data, copy on the same cloud. What we have decided to do at WEKEO level is to try to interconnect existing centers, of data. Okay, this for two reasons. First, to reduce costs. Okay, we don't want to duplicate some big data sets. The second one is that for some, let's say, data set, for instance, the one in near real time, the fact to do a copy is creating an additional time to do the copy. So if you can access directly to the original data when it is, let's say, created or downloaded, you gain some minutes. Sometimes it's important. So what we are trying to do here with this thing, it's a complex system. I will afterwards show you a very impressive slide on that. But we're doing something that is really creating a new approach with this extension to with this possibility to integrate different partners like this drawing on the bottom. So technically speaking, this is like that. I'm not going to detail that, but the idea just to understand is that in front of the data set, what we put is normally, apart from the, let's say, just access to the local storage, we put what we call a DPI. That is not the standard way of the DPI acronym, but this is a data processing infrastructure for which you can send, some Dockers to do some local extraction of things and local processing in order to not to generate too much also, let's say, traffic on the network of WEKEO. So this is bringing us something that is, I think, very interesting for this let's say, this session. You can, in addition to all the other, let's say, services that you have here that are let's say, access to data, user support, and new processing environment, we propose you to federate some data sets inside the WEKEO community. Okay, you have a data set that is available. You want to, let's say, to share it with the rest of the world. You can go and be, let's say, after a processing of labelization and things like that, you can add it to the WEKEO offer. It's open. It's something that, for sure, we have some, let's say, some legal constraint on that. You have to be responsible of this data set, and especially what is important for us is the user support. We don't want to distribute some data without someone answering the phone or at least the email when we have some question about this data. So there is also some quality label to be passed. But once you have that, you can be, let's say, integrated as a WEKEO partner. And this could be the kind, for instance, with the local distribution system here, in order to serve better your, let's say, your user. And why not finding also a local, let's say, processing partner, okay? Not to have, to go on a cloud in Europe to do your processing, but you may have this concept apply here. We're getting some access through what we call our harmonized data access to data set in Europe, but also with, for instance, especially for Sentinel-1 and Sentinel-2, getting access to your local copy here to avoid the distribution. So this is something that we need to work on together. And that's all. Thank you very much.
Thank you.
Ouais, alors attends.
Alors, comment ça marche pas, ça veut
C'est
dire
quoi ça? Qu'est-ce que c'est ça?
Voilà, tu dois ferme.
What can Copernicus do for the Pacific? And we hear some examples from the different services. The first one would be Cécile from Mercator Océan International. They are in
Non, mais
charge of
tu fais pas
the
ici, là?
Copernicus Marine Environment
Si
Service.
je fais ça, je
Vas-y, là, on les voit,
I
regarde.
still give time for our little issue here with our computer, but I just want to thank you for all
Ça marche?
coming here. I know that this
Attends, c'est un
is
autre
precious
système.
lunchtime for
Ça
you,
marche.
but
Non, mais attends, mais après.
Non, tu fais laisse
C'est où?
les flèches.
D'accord.
Où l'espace.
D'accord.
If you have time, we're still, for the rest of the GOV, we have the booth there and we have a lot of presentations for you to look at. So, Cécile?
Okay. Hello, everybody. I'm glad to be there. So once again, Mercator Océan. Mercator Océan, what is it? Mercator Océan is a small team, actually. We are based in Toulouse. Our expertise is around ocean modeling and ocean forecasting. And we have been entrusted by the European Commission to implement and to operate the Copernicus Marine Service. But we are also engaged in the WEKEO building. So I've tried to make something quite short. I have 5 minutes, so I will be quick. In a nutshell, of course, Copernicus Marine Service, as the other services, is a matter of data. So we are using space data. Astrid presented the Sentinel fleet, and we have got also in situ data. And then the expertise of Mercator Océan and of all partners of the Copernicus Marine Service is also to modelize, to have models in the catalogue. So from the global and from the regional side. Thanks to this data and these models, we're able to depict the ocean, to have a picture, what we call the blue ocean, the white ocean, and the green ocean, basically the physics, the biogeochemical aspects, and also the ice. Basically, the products you can find in the catalog are around the current temperature, sea ice. You have plenty of variables. In the past, what we call the reanalysis, the real time, and the forecast until 10 days. We are serving a lot of markets, actually. We support economy, but also policy makers, from water quality to society and education, from safety and disaster to marine navigation. Here you have got a quick look on the portail, the current portail of the Copernicus Marine Service, with an easy access to ocean products. We've got so far 180 products with a dedicated service desk and user support, which means that as soon as you are registered, you will receive systematically information from the support from the service desk to inform you about information related to products, or to new versions, or to events. So it's important also to register, not only to be able to download data, but also to be informed about what's up as far as the portfolio is concerned. In the portfolio, you've got as well, since a few months, ocean monitoring indicators. They are online, they are fully assessed, as all products in the portfolio, by the way. And it allows us to produce a yearly ocean state report. This year is a third report, and with a special focus on the Pacific Islands. I will speak about that later. So as far as Asia and Oceania is concerned, I try to let's say, have some takeaways related to user uptake. On the left side, you've got the global user uptake with a number of Copernicus Marine Service users, and then the download volume of data. So what is important to see as far as the global user uptake is concerned is that business is representing 20% of CMEM's user, but nearly half of the downloaded volume of data. as far as Asia-Oceania is concerned, you see that business is so far quite low, and I hope that thanks to this kind of event, it will increase more and more after a few months. But the business is downloading more volume of data than, for instance, the research or the government agencies. The top 5 as far as the user uptake is concerned is China, Republic of Korea, Australia, thank you, Australia, and Japan and Indonesia. They represent, all of them represent 90% in user and volume terms, both. And now 2 use cases just to show the value we can bring. Here is a use case around biogeochemical data because it's concerning the fishery predictions. And here it's interesting also to notice that we are producing core data. So between us and the end market, there are always intermediate users who are making value thanks to our data. They are bringing their own expertise and they are delivering a service to end user. In this case, it was CLS. And CLS has driven an important project called Indezo, which allow Indonesia to predict changes in fishery resource. I take the opportunity of speaking about new products which are maybe more interesting also for the Asia-Pacific region related to micronecton and zooplankton. And here, a second use case more related to physics concern the maritime industry, because the more you are able to have accurate forecasts in terms of currents, the more you help users to save money, because the routing is more accurate. So it's important for us to enable our users to have the most accurate data. Here, the average level of savings thanks to current routing is, let's say, 0.4% only for the line Europe-China. So it's very important in terms of tons of fuel saving, but also in terms of CO2 saving. Et là, maintenant, ça y est, je l'ai perdu. Il me dit quoi? Il me dit cancel, je sais pas. Voilà. And then, so it's not really a use case, but it was important for me to mention that in the third Ocean State Report, tu peux le montrer s'il te plaît, Alain? Il est là. So the Ocean State Report, bravo. Tout ça c'est enregistré, c'est prévu. So the third Ocean State Report, there is a Copernicus Marine Atlas for the Pacific Ocean States, so providing essential ocean variables, very important for these states which are very vulnerable. And so this information and the Ocean State Report is available, of course, online, such as a summary of the Ocean Report, which is maybe more easy to understand for non-scientific people. The same. And just thank you. It's okay, Astrid? Yeah. Alors, attends. What I understand.
Oh, that works. All right.
You are here, no?
Yeah.
Voilà. And normally it's here to change the slide.
All right. Okay.
And they are our entrusted entity working for the implementation of the Copernicus Climate Change Service and the Copernicus Atmosphere Service. And now, floor is yours, Fabio. Thank you.
Thank you very much. So you said already everything. So I probably can skip this slide. But maybe just I can add that beyond operating the atmosphere monitoring service and the climate change service, ECNWF also cooperates and contributes to a few other services. But back to the important ones, let's say, or the ones at least that we have been asked to talk about today. So the first one is the atmosphere monitoring service. So this slide shows the value chain, so starting from the observations. I will not talk about the regional models because they cover just the European domain, so that's not relevant here. But we run the atmospheric composition forecasting system model, which is global and takes data from observations. And basically, the atmospheric composition represents the state of the atmosphere, covering aspects like the desert dust plumes or transport of atmospheric pollutants and ash plumes from volcanic eruptions and more. And from these type of products, then downstream services produce services for instance, the renewable energy industry and apps for public, and there are also news on TV about air quality information. So yeah, the products I mentioned a bit what we do. Basically, the portfolio is very vast and produces near real-time analysis and forecasts and reanalysis of parameters, including aerosols concentrations and greenhouse gases and more. And we have radiative forcing, solar radiation. Policy tools are interesting, but again, they cover only the European domain, so I've not mentioned those. And fire and more emissions that are both products in their own rights and are also used as input to the model. So some applications, let's say, in this area of the world. There is this app that have been developed here in Australia for providing to the public information about the UV index and sun protection times. I should mention another app that it's not here, but it's in my phone. It's Windy. It's a pretty popular app, and since a couple of months ago, it started including also air quality information. You can check it if you have it. And then I mentioned news on TV. We have a contract with the CNN that provides air quality information globally. And in Europe, we have a contract with Euronews. Going to the climate change service, the aim of this service is to provide quality controlled information about past, present, and future climate information. Again, there is a vast portfolio of data. The backbone of this service really is the reanalysis that basically provides data about the state of the atmosphere from 1979 to present. And, but also we have observations, climate data records, essential climate variables. And then looking into the future, the outlooks, we have a seasonal forecast. We run a multimodal forecast with contributions from ICNWF, Meteo France, Met Office, Deutsche Wetterdienst, I'm missing some, NCEP, and the Italian Euro-Mediterranean Center for Climate Change. And then we provide also climate model simulations and information specific to certain sectors like forestry, agriculture, and water management and more. So I said the basic thing we do is really the reanalysis. Is maybe the most important, and the seasonal forecast. So using the reanalysis, we can build these anomalies and these animations of evolution of, in this case, a surface air temperature. And we have also provide anomalies about hydrological variables. And this is provided globally. And then another product that is of interest for this area of the world is the set of sea level products. For this, we work in close collaboration with the Marine Environment Management Service. And again, we provide global data and also specific products around Europe. And also an interesting activity that involves also this area of the world is the Climate Data Rescue Service. So we do this in collaboration with WMO and this Atmospheric Circulation Reconstruction over the Earth initiative. And the idea is to recover paper records and digitize them. And a few areas in the world have been highlighted as a high priority, and that includes Australia and the Pacific. Last, but very important, is the way we provide these products. So it's via our main tool is the Climate Data Store. This is for the climate service, but soon we'll also have a sister infrastructure that is called the Atmosphere Data Store. And in the Climate Data Store, you have all the reanalyses and observations and so on. I should add also that from next year in 2020, the reanalysis will extend back in the past to 1950, so 1950 to present. And will include also land surface reanalysis at higher resolution. The atmospheric reanalysis resolution is about 30 kilometers. The land surface will be about 9 kilometers. And ocean wave reanalysis as well. Plus, actually, also reanalysis from something else, which is not the climate change service, but is coming from the emergency management service, and is river discharge reanalysis. And that's available actually from yesterday, I think. It should be, yeah, from the 5th of November. Yes, and the thing about the Climate Data Store is that it's not just a way to download the data, but it's a way to display the data and to work with the data remotely without downloading. So this is a bit a precursor to DIAS, really. But it's already working, it's operational. And so people can do, users can do some operations like statistical operation, means standard deviation. They can display the data, do regridding, and some operations like that. But the future certainly is in DIAS. This is really still a bit limited in terms of the kind of freedom you have to use the system. And I think that's probably everything I have to say. Thank you.
Thank you very much,
Ciao.
Fabio. Our technical partners are the European Space Agency and EUMETSAT. And I would like now to introduce Vincent Gabario from EUMETSAT to talk about the cooperation.
Yes, thank you, Astrid. Good day, everybody. It's my pleasure to be here in Australia. I was there 20 years ago. I was studying in the University of New South Wales in geodesy and surveyor, so it's a pleasure to be there again, touching ground with some practical example in the region. So, as Astrid said, EUMETSAT is one of the partners of Copernicus. Our main role, I think, is I can explain. If I can explain it in 2 words, it's quite easy because you have just seen 3 services for Copernicus, the marine one, the atmosphere, and the climate, which have in common that they need continuous and global monitoring of the current states. And what EUMETSAT is doing as an operational space agency is exactly that. We are having a fleet of satellites that provide continuous observation over time. For us, what is really important is not the new technology having the latest measurement, but really in providing this continuity in a reliable way, information to feed those services, because as they are operational, they have big expectation from their users that they can provide continuous services to either commercial application or critical application for the safety of life. So in towards EUMETSAT, we are an intergovernmental organization with 30 member states. We have been funded by 30 years ago by our member states, and our core mission is to operate and exploit operational meteorological satellites for weather forecasting, but also for the operational monitoring of climate and the detection of climate change. We do operate different types of satellites. Geostationary Meteosat, they are not relevant for these regions, but you have similar one, by example, Imawari-sat from the Japanese, or GOES. Polar orbiting satellites also, both for meteorology, but that's also part of our contribution we do to Copernicus. We do also operate some polar orbiting satellites, which belongs to the Copernicus Sentinel constellation. I will come back to that. One example, if we stay a little bit in the meteorological domain, is, by example, the EUMETSAT Polar System. It's a satellite that has a global coverage. We do that also in close cooperation with the US and the Chinese, which have very similar satellites. And some of the applications from these satellites, notably over the Pacific Ocean, is, by example, the detection and the monitoring of cyclones. Here you have, by example, the Dona cyclone, which was a very particular one in May 2007 in the South Pacific. You have an image taken by METOP, and you have also the Imawari, which is the geostationary satellite from Japan that was monitoring that. Another example of application in the region, you have a lot of volcanic. This is most recent volcanic eruption that's very north in the Pacific, in the Kuril Island, on 21st June. So that's, you have an Imawari images that you can start see the plume of these eruptions in different color interpretation that you can do with these satellites. And by example, on board of METOP, we have a specific instrument that can do the measurement of the CO2, and that you see it at the moment of the eruptions and how it spread in the atmosphere later on. So in short, also, you have a lot of benefit from this polar orbiting meteorological satellite, because they basically feeds the numerical weather forecasting models, by example, the one of ECMWF. And what is interesting in this complicated graph is that you see over time the number of satellites data which are assimilated by the models. And on the right-hand side, you see for different forecasting time, the difference between the quality of forecast in the northern or in the southern hemisphere. So 30 years ago, the weather forecasting was much better in the northern hemisphere than it was in the southern, because in the northern hemisphere there was less sea and more in situ data available. While since those satellite data are assimilated in the model, you have almost the same quality today in the northern than in the southern hemisphere, and you have a global increase of the quality of the weather forecasting also, not only thanks to the satellite data, but also thanks to the progress made in the supercomputers and in the model themselves. Just also because we are an operational agency, we take care of continuity of data, and right now we are working quite a lot within EUMETSAT in the new generation of meteorological satellite data, which will provide data over the next 2 decades. So we expect to launch the Meteosat 3rd generation and the EPS 2nd generation in the early 2020s. And this program is being funded by our member states. They carry also some Sentinel instruments, by the way, and they will be there until 2040 at least to feed the different applications and services. So when it comes to Copernicus, as I said previously, EUMETSAT has acquired over the last 30 years quite some strong experience in feeding operational services that needs continuous monitoring for doing some forecast. We were doing that for meteorology, but when Copernicus decided to push and what was existing and maybe being still in a research way to create operational services for the atmosphere, for the marine, and for the climate, EUMETSAT became a natural partners, if you want, to be the satellite's data provider for these services. So in Copernicus, we have several roles. First is to feed those services with a lot of data, not only our data, also the data from the Copernicus Sentinel missions, but also we work with our international partners in China, in the US, in Japan, in Korea, in order to bring to Copernicus some satellite data from other missions available worldwide that can be relevant for that. We are also contributing to the climate change service by providing what we call climate data records. At EUMETSAT, we have more than 30 years of data as archive, and there was this morning a lot of discussion in the climate session at the plenary, but we work a lot with our international partners in order to provide climate data record that corresponds to the essential climate variables defined by GCOS. And this type of climate data records over several years, measurements made by satellites, then feeds the Copernicus climate change services and other area. Another examples, now I'm coming more to Copernicus, with the ocean circulation sea level rise. With Sentinel-6, we will continue the continuous monitoring of sea level rise, and you can see here, for example, for the Pacific, the variation of the sea level rise in the different area of the Pacific. The Sentinel-3, as it was said by Australia, it's a global and continuous coverage. There is several applications, but they were presented much better than me by Mercator, and you can see chlorophyll, you can see sea surface temperature. So with this type of Sentinel data, you have a lot of application, either directly with the data or through, for example, the Copernicus marine missions. More specific to the Pacific region. So, of course, there is a wealth of data and product, not only from the satellite, but also from the Copernicus services. But barrier exists. So I attended on Monday and Tuesday some of the sessions dedicated to the Pacific, and it was obvious that there is two main barriers: access, knowledge that those data exist, and access to them. It's remote islands with not sometimes difficult internet connections, and then to have the capacities to exploit those data, not only human, but also in terms of infrastructure and sometimes also institutional capacities, because you might have a university that is able to access and do, but you do not have the institutional framework to really have an impact with those data in the regions. So we have been working a lot on data access. Obviously, we are less pertinent in the Pacific than we are, by example, for Africa, but we have a system like GeoNetcast, which is for data push. It's not internet-based, it's satellite communication-based, and this could be something relevant for the region. We have also, it was presented before, some more standard online data access like CODA or EUMETView, and we are partners to develop the WEKEO to provide cloud-based computing. So two things. One, GeoNetcast. This is a data dissemination system put in place by EUMETSAT, NOAA, and CMA in order to push data to the user with satellite telecommunication. And you can see that there is, but we would like to investigate a bit more with our colleague from CMA what will be the possibility for some island in the Pacific to connect to CMA Cast and to receive through this channel some data. This type of technology is based on digital video broadcasting, so it's relatively cheap. That means it's an affordable technology. It's not something very sophisticated. You can watch soccer or rugby match with it, so you could also, with the same type of technology, access quite a lot of data. It's not a two-way communication, so you only receive the data. We have a similar version of EUMETcast, also data push, but which is done with Géant in Europe in terms and working on education network, which actually was used also in Australia in something that could be also envisaged. On capacity building, so it was said by Astrid that Copernicus does not have funding for international cooperation, but when it comes to developing countries, the European Union has some also specific activities, and notably the European Development Funds which address specifically the needs of the countries from the Cotonou Agreement. That means in Sub-Saharan Africa, Caribbean, and Pacific. And following a declaration that was done in Benoni in 2014 from Africa First, there have been the formulation of an 85 million euro program, which is there to support the establishment of climate services in Africa, Caribbean, and Pacific region. And the Pacific regions, through the SPREP, the Secretariat for the Pacific Regional Environmental Programme, has been allocated a grant of 9 million euros, and they are currently drafting it, so in order to participate fully in this program. Some of the main principle on this European Development Fund is ownership by the region. So basically, what SPREP will propose is based on regional policies, and I mentioned some here. That's what the UN SEED summits, the Samoa Pathway, and the Declaration of the Pacific Ministerial Meeting. Some regional needs and priorities, and the region has already developed a roadmap. I've already selected some of the priorities they would like to work on in terms of climate services. This is, without too much surprise, disaster and climate resilience and food security, including fisheries. And the last point is also to work and to be aware of the regional realities. So this program, which is for us, and that's my last slide, an opportunity to work much more closely. It's a region we don't know, I have to say. So, but through this program, I think there are opportunities to establish some more concrete link, and notably to with these grants to make sure that some capacities are strengthened in the region, notably to better access and use existing data and product for climate services, essentially the Copernicus Climate Change Service, but also maybe the marine one, some EUMETSAT climate data records, and to support the establishment of climate services in the regions based on what Copernicus can offer. Thank you very much.
Thank you very much, Vincent. Now we have what is called the industry track in the session.
This one?
This is Rory Donnelly from the European Association of Remote Sensing Companies.
Je suis this.
Because I think we will have a session now starting. Just for your information, Rory gives a presentation. Now we have Mr. Forstreutner here, who is living in the region in Fiji, who will give a presentation. And then, of course, we'll do question-answer session, have the benefit of all the colleagues here. And then, you ready to go somewhere else and go back to the plenary or visit the exhibition. So, Rory, to you.
Okay, good afternoon, everyone. My name is Rory Donnelly. I'm an Australian, but I've been working in Europe for the last 10 years. I'm now working for the European Association of Remote Sensing Companies. Now, we've heard a lot earlier in the week about the specific challenges in the Pacific and the possibility for Earth observation services to bring meaningful benefits to Pacific Island nations. So I'd like to bring a slightly different perspective to today's presentation by giving some experiences from the development of a robust and thriving commercial sector in the Earth observation sector in Europe. How am I going to do this? I'm going to briefly outline some of the experience, the breadth of experience that we have in Europe, the public benefits that have flown from these experience and services, some of the private sector solutions that we have, and how you can also access these. So first of all, what is ERSC, the European Association for Remote Sensing Companies? It's a membership-based, not-for-profit association. We have about 120 members, and our goal is, of course, to promote our members, but more generally, as a geo-participating organisation, is to promote the benefits of Earth observation globally. We have members that are active in all aspects of the Earth observation value stream, so from upstream, putting satellites in the sky, collecting that data, distributing that data, and primarily creating value-added products so that we can target specific use cases that are of need for the end users, which is really the benefit of the the commercial approach. So there's a financial incentive for the companies to really address a key user need in a way that fits into that user's workflow. Now, this is an awful lot of logos. We're something of a victim of our own success. We're growing rapidly, and there's almost too many logos to fit on the slide. But what I wanted to show with this is just that this is a lot of companies. Each of these companies has 5, 10 services. It's a huge number of services, each targeting a specific user need. So what we've done is we've developed a range of services to help you navigate that landscape and find the product or service that can effectively tackle your need. So this is a whole range of services that we do. I'm going to focus today on just a few, on the promotion, on the market observatory, international partnerships, and these tools that can help you find the products and services. So in terms of promotion, we have EO Mag. This tells you everything that's going on in the European Earth observation sector. It's released quarterly, it's free, it's online. I encourage you to sign up, have a read. You can learn a lot about what's going on. We have a series of portals and wikis. We started with this EO portal along with a taxonomy to address the problem that we saw that the end user languages were different to the language that these more technical Earth observation service providers were talking. So we've tried to link these two through a taxonomy and a wiki. And then this was further refined into an oil and gas dedicated wiki, the OGO portal, and we intend to develop more of these thematically specialised portals in the future. We also have an annual report that tells you what we're up to, so we're held accountable in some way. What else do we do in terms of the market survey? We do an industry survey every 2 years. We get a whole range of facts and figures from this, from polling a lot of companies throughout Europe. I've just pulled out 2 things that I thought were of relevance for today from this to discuss a bit further. The first is this idea that you may or may not know about, which we call online services and bespoke services. So as the sector matures, we see a move from what I call bespoke services, which is where you might go to a university or a research institute or even a company and say, I'd like an answer to this problem, please. And they will go and get that information and process it and give it to you. What we're seeing more and more as the sector matures is that people don't want to do this. People want to click online and buy something. And so the private sector, this is part of the private sector drive, is answering this need and moving more and more towards these online services. So the other thing I wanted to pull out of this market survey was these barriers to growth. So we polled our members on what are the biggest barriers to growth, and they match really well to what was just presented a couple of minutes ago as the barriers to the use of Earth observation in Pacific region. So lack of budget, so people want to use it but can't afford it, and lack of user acceptance and let's say user capacity building. So I'll come back to those in a few moments as to how ERSC as an association works towards addressing those. So another thing that we have in the Market Observatory is these Sentinel benefit studies. So if we want to promote to countries or to governments that they should use commercial services to provide benefits to their citizens, we have to really give them a good reason why. So we have a contract with ESA to map the benefits, the societal benefits, the economic benefits, and the environmental benefits of a range of Sentinel-based services. So we've already looked at about 12 commercially available services and mapped the up and downstream value. So this leads to some pretty big numbers. How do we get to these numbers? We look at things like if a potato farmer is using a service to see where he should or how he should better, he or she should better tend to their fields, not only do we look at the benefit to that farmer, but also the benefit to the factory, who has a better view on what's coming in. The factory can organise their logistics, buying their boxes, etc. better. So there's a whole range of benefits that go up and down the value chain. But this kind of thing can show to a government that the investments into Earth observation services really pay dividends in the long run. So I encourage you to look at these full studies. We published the full methodology, so you can do it yourself. That's the address there. What else do we do? What I wanted to talk about is partnerships. So by having memoranda of understanding with, for example, Frontiers here in Australia, with other organisations around the world, this allows us to more easily join companies and institutions in these other countries with our members so that we can form partnerships, so that these institutions and companies in country who have a knowledge of the ecosystem and the needs can then join with our companies who have a range of other skills, and they can come to agreements and make trade and allow the benefits of the experiences that we've already developed to flow on to the citizens in these countries. What else do we have in Europe? We have a large amount of training. So training not only for end users, but also in training to develop services for themselves, so that other countries can develop a robust commercial sector as well. Then the tools that we have. So we have two key tools to help you navigate this landscape of this huge number of products and services. So the first is EO Pages. This was, let's say, our first effort. And in this one, I think it's great. You can go in, you can search basically for your market, your needs, and your location. And then it'll return from our list of hundreds of companies which products and services are relevant for you. So you might find Planet. You might find GMV with a forest product. You might find a maritime awareness system, depending on your needs. If you wanted data fusion, if you wanted to fuse drones with aircraft, with in situ, you might find Eurosense. If you had marine pollution, you might find Orbital EOS. And if you were interested in urban subsidence, you might find Geosystem Hellas. These are just a selection of companies, a selection of services that you might find based on your own search criteria. Agri-Geos we heard about yesterday. The other tool that we have, which is directly addressing this move to online services, is the EO Mall. So on this tool, you'll find specifically what we call the online services that you can really click and buy. So here, you might find a satellite-derived bathymetry product, or a landslide product, or a land cover analysis that's not based on a survey done 5 years ago, but it's based on algorithms run on the latest satellite overpass. You might be interested in fire scarring or predicting the path of the current fire. So all these were just a selection of things that you might find based on your own criteria. So I guess trying to wrap it all up, what I was trying to say is that with the breadth of experience that we have in the commercial sector, having been developed over the past decades, there's a huge number of benefits that have flown through to society. And these can also flow through to other societies too. And that's part of the work that ERSC is here to do, is to facilitate that, facilitate access to those services to do that, both just through us, you can send us an email, or through these magazines and digital tools that we've developed for that purpose. So, thank you very much.
Thank you very much, Roy. ERSC has also a booth just across the Copernicus booth. So I would like to take the opportunity to invite Mr. Corstorter to give a short presentation. He is a German, coming from northern part of Germany, but also a Fijian.
Yes, I have a Fiji passport.
So, and you have a presentation?
Yeah, it's
yes,
over there.
Go with the presentation. Wonderful. He has been giving Copernicus presentation in Fiji for remote sensing company, right? That's the company for us.
No. I was told to talk about Sentinel and Copernicus application in the Pacific? There is not really one yet. There's two reasons. One reason is it's not really known. The users don't know about Copernicus. The second reason, the data was simply not available. This has changed, and I want to explain. Will it work?
Yes.
Yeah, okay, good. I can't hear. Where is the potential application and what are the limitations? Okay. Oh, man. I have to. We're all getting older. So, this is all clear. When I see what is in front of my, then it's fine. I'm not anymore working, but I was working 22 years with or for SBC. And what we did mainly, and what I like to do, is implementation of technology or know-how transfer. So we were in the position to order image data on behalf of the countries. The countries cannot do image data purchase by its own. The countries are very limited in resources. A country, for example, to give one example, Niue. It's our own country with a seat in the UN. How many people, inhabitants, for example? 800. Other countries, 4,000, 3,000. So we do the stuff in behalf of the country. We did. Not anymore. We managed to distribute all data for Digital Globe on Forestec. It's passed, but I am showing this to explain why we have an overview when I look back the last 15 years, roughly. This is not a statistic really built up, just I made it up a couple of days ago. It's 1 quarter disaster, 1 quarter marine boundaries, and 1 quarter forestry and agriculture. And here, for example, I see a potential need, and I will explain, and in the disaster area, I really see a need. Pacific is slightly different. If you see, the most countries are atoll islands, and you have a mapping scale of 1 to 10,000, not really applicable for Sentinel-1 or Sentinel-2. But the volcanic islands, there are applications. I first go through the normal application where really data was needed. Boundary definition, for example, this is measured from the last landmark, and this required a lot of data, but you need data with very high geoaccuracy, not really application for Sentinel right now. Something else is vegetation monitoring, and here I really see an avenue. Vegetation monitoring is not done and will not be really bought into it if it's produced outside. For example, we had to do forest change detection to see the rate of deforestation. In Fiji, has to be done in Solomon Islands, in Vanuatu, where the forester, together with people from remote sensing background, sit together and do a visual interpretation, and then it is accepted by the countries. And this can be done with Sentinel-1. We used Lancet because it still was not available end of last year. Now we are uploading the Sentinel data. A lot of countries don't have the bandwidth, so we upload and deliver via external hard drive. Very simple technology, but it's working. Other things, although these stuff is now planned, when I go back, Forestry Department in Fiji to have it permanently updated on the web, and we are using now Sentinel data. Other stuff, on the low-lying islands need a high resolution we can't provide. Disaster mapping, Cyclone Winston, for example, we have to see which house is affected, which house is destroyed, which house is intact. You need high resolution to do this. However, we have other applications. Nandi, as one example, is flooded and will be flooded again, and the flooding will be more intense because the reasons for the flooding are still there. Nandi is simply on the wrong spot built. And we used Terrasa X data to map the flooding, which is essential to map within short days. We got the data capture 1 day after the event happened, so we were lucky to have still areas covered with water, and it was much more effective to do it with radar data than do it with conventional survey where you go around. Here we really have a hope that we had to order the data. Days before we see the event coming, but it's a coincidence that we get the data captured at the right spot. If the system allows a direct download of data, this would really help. Okay, I said that Sentinel is not really known. I'm not anymore SPC, but I'm the chair of the Pacific GIS and Remote Sensing Council. It's a grassroots-based council where we have linked over the, let's say, 15 to 20 years to Pacific users who are hands-on. And here, I think a possibility exists to make Sentinel or Copernicus much better known. Yeah, I'm on my last slide, no problem. We have a user conference every year, which is the conference where you have all Pacific Islands present. It's a user conference. You have the companies, Hexagon, Trimble, whatever is available. You have scientists, and they talk to each other. Copernicus or Sentinel representative was missing. There was a European Union delegation who sent somebody, but this could really be improved. We have an email distribution list, GIS PACnet. We have a newsletter which goes back 25 years. You see the history of the GIS and remote sensing development in the Pacific. And this can be utilized, and I hope we have every year the conference. Next conference, it will not anymore be in Nandi, it will be in Vanuatu, first time after 22 years outside. We have about 300 participants, and I hope that I convince Copernicus to be present. Thank you very much.
Thank you very much, Wolf. Thanks to...
Can I just here?
Yes.
Go onto the website, PIC, Pacific Island Countries, GIS and remote sensing.org. Very easy to remember.
Thanks to everyone, especially the presenters. So one of the barriers was said that people don't know about Copernicus. I would like to urge everybody in the region, please go out, talk about our session here, talk about Copernicus is available for you, A, the data, B, the services, C, the opportunities to get support for your questions you might have for Copernicus. But before we leave here, you spent now close to 2 hours here in the room. If you have a question to our distinguished colleagues here, please ask the question now. So be very happy to answer all the questions you have.
Yeah, thank you. At the That's better. Okay, yeah, good. At the very first presentation, it was said that there are 5 tiers, so 5 entry points to the data. If as a user now, I'm looking for a specific data set, what do I do? Do I look through all the 5 tiers to find the right combination to see what is where, or is there some kind of meta engine on top where I can see like a catalog what each tier is doing?
So, yeah. Let's say your choice will not be made on the data section. We are all providing all the data. Okay, so you can enter in any DS and you find all the data you need that are part of the Copernicus portfolio. Afterwards, it's just I would say a flavor of each DS, especially in terms of additional services that can be proposed. So user support, additional data sets that are not, let's say, just the one of the Copernicus service. So this and so also the pricing proposed because let's say the renting of the environment will be the same on each day. It's why we have those 5 competitors.
Thank you, Alain. Another question?
Thank you for all those fascinating presentations. Yeah, so really a kind of practical question. If I'm Paul from SREP, I can anticipate a question next year from Nauru, from Kiribati, from Vanuatu asking about air quality. I know there's very little nationally produced air quality data. There is air quality data apparently available from Copernicus. Is there a table of records for Vanuatu of air quality measurements over time, or is it just the image?
There is a reanalysis of those statements.
That'd be fantastic.
And also numerical data.
It's terrific. So I can think of some very specific uses in the coming months for some of the data. If I could just get a little guidance on how to find it, I can apply it and give credit to Copernicus for providing great data.
Yeah, so just
Thank you so much.
maybe it wasn't clear as the data are available. I show the images and the graphical data, but they are also the numerical data that are also valuable. That's true for the reanalysis and the political.
Thank you. Any other questions?
May I just add something on
Yes,
top
you
of
can
that?
ask.
You know, what Astrid mentioned at the beginning, that also it's very interesting for us to be collecting, let's say, the in situ data for all those places in order to improve the model you are using there, because you may have some situation for which, let's say, the global model that is used based on the satellite data maybe has not a sufficient resolution to catch some important information at the local level there. So it's important, to be able to ingest some in situ data in our model to improve.
In some cases, like air quality, there might be nothing locally.
Yeah.
So whatever you have might be the best there is.
Okay.
It's fantastic to use.
Thank you. So, any other questions, remarks, concerns? No? Carmen, you want to say something? No? Okay. Okay, so I think that we come to the close of the session. I would like to thank all of you for your time, and especially our presenters for preparing the presentations. I hope you remember Copernicus, look it up on the Copernicus EU website, test the DIASys, test the regional data hub, and see what Copernicus can do for you and for your entity and for your region. And we are very open to discuss with you how we can support you and cooperate.